Hello and welcome to the Kick Sugar Summit, the world's first summit on the topic of sugar, sugar addiction, and sugar addiction recovery. We know that if we're going to reverse our rising rates of chronic disease, we need to reduce or eliminate our consumption of sugar and refined carbohydrates. We are here to help you do that. There are a lot of speakers on our summit and a lot of information. Don't get overwhelmed. Catch who you can and just let the rest go. Alternatively, you could purchase one of our Summit VIP packages, which comes with an awesome ebook summarizing the core insights of each speaker, a year's worth of resources from our world of experts, and access to a whole year of weekly drop-in live Q&As with me, Florence, your host. Thank you for being here. I hope you love the summit, and I hope it changes your life. Hello, everybody, and welcome to an interview today with Dr. Richard Johnson. Let me read you his bio. It's long and amazing, and he is an MD, a practicing physician. He's also a medical scientist who's been working as a medical scientist for over 25 years. He's internationally renowned for his work regarding sugar, the role of fructose in particular in diabetes and obesity. And today he's going to talk a little bit more about uric acid. His research has shown that there's a fundamental role for uric acid, which is generated through fructose metabolism. Little known facts. We're going to explore that today. And it's a key component of metabolic syndrome. Dr. Johnson is a prolific scientist who has had his research funded by the National Institutes of Health since the 1980s. He has published over 700 papers, lectured in over 45 countries, and his work has been highly cited. He has 3 books, all of which are brilliant and amazing. His most recent one is called Nature Wants Us to Be Fat. And if you haven't read that book yet, please do. It's on Audible. I listened to it on Audible, and it's kind of like a page turner. Because it's like one of those, there's these plot twists. You're just like, what? The body can manufacture fructose, even if you avoid eating it in your diet. Like your body can still manufacture it when you're dehydrated. And it's fascinating. The science in that book is just riveting. He also has 2 other books, one called The Sugar Fix and The Fat Switch, which is all about how high insulin switches off the fat burning and puts on the fat storage switch, which is why anything that spikes insulin can lead to weight gain and stubborn weight gain. So welcome, Dr. Johnson.
Thank you. It's wonderful to be back on your show.
And what's also a little bit interesting about Dr. Johnson is he self-identifies as having a bit of a sweet tooth himself. And at the end of his book, Nature Wants Us to Be Fat, he wrote a poem. The scientist, the Dr. Johnson wrote a poem, and it's all about how that sneaky sugar has snuck into our food supply and truly making us unwell. Dr. Johnson, I know you've shared this story many times, but for people who are new to you, tell us a little bit about how you became so interested in the topic of sugar and how this has really become your life's work.
Yes. Okay. So I'm a kidney specialist by training, and, I'm board certified in internal medicine and kidney disease, and I'm a practicing physician. But I also have been doing research, and initially, my research was focused on kidney damage and kidney injury. What causes kidney damage? How does diabetes and high blood pressure cause kidney damage? And then I became more interested in what was actually causing hypertension and diabetes rather than just how they cause kidney damage, but what is actually at the basis of those diseases. And they're often coupled together. And that actually took me on a route where I ended up studying the substance called uric acid, which everybody makes. But if it's very high in the blood, it can cause a disease called gout. But interestingly, the uric acid is associated with high blood pressure, kidney disease, and obesity, and all of these things. And I began to realize from our research that the uric acid was actually playing a role in these conditions, which had been hypothesized by some people all the way back to the 1800s. But, we were able to sort of prove it. And as we started realizing how important uric acid was, we wondered what was making the uric acid go up. And one of the causes is sugar. Sugar is actually two carbohydrates that are combined together. One is glucose and one is fructose. When they bind together, they make the disaccharide or the double sugar called sucrose, and sucrose is table sugar. But it turns out it's the fructose component that makes the uric acid, and fructose turns out to be a really significant player in driving metabolic syndrome and obesity. And it isn't just the fructose we eat from table sugar; we can make it, as you pointed out.
And
So
that's the
my
shocker.
road took me from the kidney to these diseases, diabetes and hypertension, to uric acid to sugar. And in the process, there were a lot of discoveries, and we were one of the first ones to prove that sugar worked beyond just being a calorie. And so we've been in this field since a long time, unfortunately. But anyway, I'm happy to talk about what we found.
Right. So basically what you're saying is you're looking at what the kidneys are being damaged, diabetes, high blood pressure was damaging, and you just kept working upstream, and all of a sudden you landed, root cause here, root cause, a big piece of it are these refined carbohydrates that have flooded our food supply. Amazing. So tell us a bit about uric acid. What is it for people who don't know what it is?
Okay. So, our body's made up of protein, carbohydrates, and fat, and cartilage and bone. But within our cells, we actually have what's called nucleic acids, DNA, RNA, and other things that we use to actually kind of orchestrate what's going on in our body. So the DNA makes up our genes, and the RNA is what drives protein production. And those are made up of nucleic acids. And when nucleic acids, they're kind of nitrogen containing substances, they're little chemical compounds. And when they are broken down, the end product is uric acid. And so there's always some turnover when we're, and we can produce and make this stuff as well. So our bodies are always making some of this stuff. And we don't want to accumulate it, because if it gets too high in our blood, it can precipitate into crystals, and commonly those crystals will deposit in our joints. So if we do have too high a uric acid, it can form crystals in like the big toe, and you can get this really painful disease called gout. And there are about 9 or 10 million people in the United States that have gout, maybe 3% of the population. So it turns out that, it's an important disease, and people who get gout, it's very painful. But what happens is we normally try to get rid of that uric acid when we make it. So we use our kidneys to get rid of it, and some of it's excreted in the gut. But it can accumulate if we make too much. And one way we can make too much is by eating a lot of sugar. But other things can do it. Alcohol makes uric acid, and also certain foods like shellfish and, some of the meats, that are particularly, things like mackerel, some fish like mackerel and anchovies can raise our uric acid. So shrimp can do it. And so there's a number of foods that can raise uric acid. And if people get gout, they're usually told to cut back on sugar, to cut back on shrimp and shellfish, to cut back on alcohol. But what's been known is that people with gout frequently are overweight, frequently have high blood pressure, and frequently are diabetic. And for a long time, it was thought that, it's just because the foods that make us obese, like sugar and fried shrimp and things like that, that those kinds of foods cause obesity, and they also raise our uric acid and cause gout. So it's because of the food we're eating, and other things too, our kidney function, because the kidneys get rid of uric acid. So if the kidney doesn't work as well, you'll start to retain uric acid. So it was thought for a long time that the uric acid was although it's high in people with gout and it's high in people with kidney disease, I mean, excuse me, it's high in people with obesity and diabetes, and but that it's really not driving the obesity or diabetes, but rather that it's just another manifestation of the kind of the diet and everything people are doing. But what our work found, which was really exciting, was that the uric acid is not just a passive participant. It's not just accumulating because we have obesity, but it actually has a role in causing obesity and diabetes and hypertension. And David Perlmutter wrote a beautiful book on this, Drop Acid. And my book also talks a lot about this work on uric acid.
One of the
I recommend people to read David Perlmutter's book. It's a great book.
Okay, and I haven't yet. I've heard of it. I'll get it on my list. So one of the things that was so shocking to me in your book, Nature Wants Us to Be Fat, and you were talking about uric acid and fructose and how fructose drives uric acid accumulation, is that when we're dehydrated, there's a pathway that inspires the body. I hope I have this correct. Inspires the body to start to produce on its own accord fructose. And it made me wonder if people will unconsciously choose to stay dehydrated to manufacture fructose sort of internally. What do you think of that idea?
So yes. So let's just talk about this because it's really important. So it turns out that everybody sort of focused on two main things driving obesity. One is, sugar and carbohydrates and high glycemic carbs. And they absolutely do drive obesity. There's just no doubt about it. There's so many papers. We've shown it scientifically. And when you eat high glycemic carbs like bread and rice and potatoes, they actually, some of that gets converted to fructose because fructose is made from glucose in the body, and glucose is in starch. And so when you eat a lot of starchy foods, you can make fructose. And we actually were able to show that one of the main reasons the low carb diet works is not only because it doesn't stimulate insulin, but because it also doesn't make fructose, because you get your fructose from either the fructose you eat, which is a carb, or from the glucose, which is also a carb. So if you're on a low carb diet, you are effectively reducing the amount of fructose that you either eat or make. But there was another mechanism that we discovered, and it was really interesting. And this is what you're talking about. And that is that there's a lot of people who eat salt and salty foods. And I know that there's a literature saying that, that first off, there's a big scientific literature showing that high salt intake, especially in people predisposed, can lead to hypertension. And can make hypertension worse. And for sure, it can make hypertension worse. And most people, when they're born, they can eat a lot of salt without a problem. But as you get older, you start developing trouble excreting salt. And so there's a big link of salt with hypertension. It's been challenged in the lay literature, but I mean, I've written 100 papers where I studied this in people and animals. It's real. Salt in the people who are predisposed, not everyone, but in people who are predisposed, definitely drives hypertension. And if you do have high blood pressure, reducing your salt intake is beneficial. But there's also a group that says that salt is good and you need to have your electrolytes. And certainly if you're an athlete and you're working outside and you're sweating, you often need to eat more salt than normal. And also, if you're on a low carb diet, you oftentimes have to eat a little bit of salt, especially in the first month, a little bit more than usual to help keep everything going, because you can lose salt and water during the first few weeks. So it's kind of been a controversial topic. But anyway, when we were studying salt, we had a big discovery, and I'll point this out because it turns out that when you eat salt, the salt, when you absorb it, transiently makes the concentration of salt in your blood high. It makes sense, right? You eat salt, it has to go somewhere, it gets into your blood, and it makes the salt concentration high. And when the salt concentration is high, that triggers thirst and makes you want to drink. And that's why if you eat salted popcorn, you're going to get thirsty and you're going to want to drink water. Okay, so far that's quite understandable. What's known though is that the way that body converts glucose to fructose is stimulated under high salt conditions. When the salt concentration goes up in the blood, that actually triggers the body to make fructose. And it works on the enzyme that converts it. And the enzyme is sensitive to salt concentration. So if you give an animal salt, it will start to make fructose, especially if you're giving it carbs, because carbs are how it converts the glucose to fructose. And that's why French fries, which are salted, are much worse than potatoes that are not salted. And then, of course, the French fry has the fat. So the salted fries makes fructose, which makes you hungry. And then the fat gives you the energy, the calories that make you gain weight really rapidly. So it turns out that salt when you're eating a lot of salty foods, it can actually stimulate fructose production. And so what we did is we took animals and we just put them on a regular diet. And then we put them on a regular diet with salt. And guess what happened? When you give them salt, they actually trigger this production. They get hungrier, they eat more, and they start gaining weight, and they become obese, diabetic, everything. So it's been known in the literature. And in fact, all my friends that are doctors that are working in obesity clinics and so forth have known forever that people who are overweight tend to eat a high salt diet. I mean, everyone does, but especially if you're overweight. And you can show that by measuring the salt in the urine, because you eventually get rid of the salt. And so they're getting rid of more salt per day than the normal person because they're eating more salt. And what we found is that and actually it's just been kind of described now, maybe in 20 or so papers, that people who are overweight are eating more salt. And that if you do eat more salt, even if you're not overweight, that will predict weight gain. That will predict obesity, diabetes, hypertension. And in fact, if you put a person on a high salt diet, this was done, in 7 days, they're insulin resistant. In 7 days, insulin resistance can be induced. Yes, beautiful clinical trial, proven. And so salt really is a powerful driver. So guess what? They've done studies. There's a wonderful doctor named Dr. Jody Stuckey, who was one of the very first people to look at this. And she's always been a believer that people aren't hydrating and aren't drinking enough water. And she showed that people who are overweight tend to drink less water and eat more salt. That is a formula for activating this fructose pathway. And when you eat the fructose, it triggers this switch where it actually makes you hungry, thirsty, want to eat more. You lose your weight regulation, start storing fat. Everything can be triggered by this fructose production. So it turns out that this is another way to become a fat. You do not have to just eat, it's not just sugar and fats and low protein. There's another factor, salt. And in fact, we did a study in people where we gave soup with salt in it. You can mask the amount of salt in soup. And we could show that if we gave them salty soup, that we could trigger this switch. Their blood pressure shot up within minutes. And if we gave the salt with water, the soup with, they had to drink water so that their salt concentration didn't go up in their blood. So we neutralize, even though they're eating the same amount of salt, if we give them enough water to prevent the salt concentration from going up, they didn't activate this switch. Their blood pressure stayed normal. And so then what we did is we took animals who were on a diet to get fat, and we just started giving them water, and we could definitely dampen the development of obesity and diabetes. And so what we learned is that there's two things. One is if people eat a lot of salt without drinking a lot of water, or even drink a little bit less water, that's a risk factor for developing obesity and diabetes. But you can also help block that by drinking water. And the normal amount of water that's recommended is 1 to 1.5 liters, but the data shows that really it's closer to 2.5 liters a day, maybe even 3 liters a day, that will actually optimize your health. So I would recommend most people to drink that classic recommendation of 8 glasses of water a day. There's actually data supporting it. Now, I don't want you to drink huge amounts of water because you can intoxicate on water. And if you're running marathons, that's been the classic place where people drink tons of water and then they drop their serum sodium. So their blood gets, instead of salty, it becomes less salty than normal. And that can, if it gets really low, it can cause problems. So, but 8 glasses of water a day is pretty darn safe. And it's what I recommend. So anyway, so getting back, salt is a unrecognized, non-caloric driver of obesity.
And looking through the addiction lens, I've noticed for myself, I didn't particularly care for fruit, not really, a little bit when I was a kid, but I was all about the sugar and the salty snacks, but more the sugar. And then eventually, when I pulled those out, my interest in fruit definitely shot up. And I confess I've eaten as many as 12 little mandarin oranges, total binge. I've eaten 4 bananas in one sitting. Like, I could see this escalation. And I know that for me personally, and I have a very sensitive brain, that when I eat fructose, and I'm talking about healthy sources of it, just in fruit, even then I can get a little lift, not just energy. There's like this little lift, the lift that I notice that I can get from sugar. And I wonder if it lights up my addict brain. Like, for me, I wonder. And then it occurred to me that for people, when they're chronically dehydrated and they've activated this fructose pathway, if they're just self-intoxicating with their own internal fructose.
Yes. So let's talk about that. So first, let's just talk about fruit because it's so important to understand. When I say fructose is driving obesity, everyone says, what does that mean? Does that mean I can't eat fruit?
Right.
No, you can eat fruit. In fact, eating some fruit is good. It turns out that it's really high concentrations of fructose that drive obesity. And when you drink a soft drink, you're saturating your system with fructose. And if you're eating lots of sugary foods, but natural fruits, an individual natural fruit only has like 4 to 8 grams of fructose, and the intestines remove the first 5 grams safely without doing anything. So it turns out that you don't really get a lot of fructose from just one fruit. And, so if you ate a 1 or 2, even possibly 2, but I would say like a fruit at each meal would be totally safe. It would be good, and it would be healthy because the fruit contains vitamin C and flavonols and all these things that are good. Fiber, the fiber slows the fructose absorption, and it's the fructose concentration in the liver. So if the fructose trickles in because of the high fiber content, it's not going to be a problem. But if you drink fruit juice where you get a big dose, or if you eat a bowl of grapes, or if you eating 10, if you eat 4 bananas, you're going to get a dose of glucose and fructose, and it is going to make fructose in your body, and it probably will give you that. And when you eat sugar, there's an initial kind of elation and then a kind of a crash. And we think the crash is related to the fact that energy levels fall in the, after about 20 minutes, they start falling really significantly in the liver and elsewhere. And there's there's 2 kinds of energy. There's active energy, which is ATP, and then there's stored energy, which is fat. And the fructose tries to move the calories into the stored energy, and it will actually drop the active energy. Excuse me. So the ATP levels will actually drop. And, so it's sort of associated with, excitability and then crashing. No one's actually correlated that with the ATP levels, but you can measure the ATP levels indirectly with a machine called an NMR machine. So it would be kind of an interesting thing to look at to see if it correlates with the hyperexcitability and then the crash that we see in children who are given sugar. It probably will, but I
Hmm.
don't think the study's been done.
I know there's a lot of seniors that are dehydrated. My mother, I'm thinking of, I'm always like,
Oh,
Mom, you're
yeah.
tired.
The older communities,
Right?
it's been shown they're not drinking enough water. And so it's sort of interesting when they've done studies and you can measure the serum salt concentration in your blood. And everybody who goes sees the doctor and gets a blood test has that test done. And almost never does the doctor or anyone look at it because it's, quote, in the normal range. It's called the serum sodium. And the normal range can go from 135 or 136 to 144. And that's millimoles per liter. But, the number's like 136 to 144. And normally people have levels of like 138 or 140 or 143, and no one notices it. But what's happened is the Institute of Aging, as well as other institutes at the National Institute of Health, have started looking at this, and they've actually realized that when your serum salt concentration is in the upper range of normal, so it's still within the normal range. But if it's like 143 or 144, guess what? It predicts about 20 different chronic diseases. It predicts aging, it predicts obesity, it predicts dementia, it predicts all these things. And it kind of makes sense because that's a concentration in the blood that would be increase your risk to make fructose and to become fat. And so I think that we should be looking at our serum sodium. Everyone should sort of want to see the serum sodium like around 138 to 142. And that is the range that's kind of ideal. 138 to 140 might even be the best. If it's 144, you're not drinking enough water.
And is it possible that fructose is psychoactive? Has there been any research on that? Is it
Oh,
potential
yes.
oh, okay.
Yes. No, when you eat fructose, although not that much fructose gets to the brain starts to make fructose. And if you give fructose to a person, you can show very dramatic changes in the brain within minutes. And, a reduction in blood flow to the areas involved in thinking, in memory, in self-control. Makes humans, when they eat fructose, you can show that they activate their centers so that they can, the visual cues, it's called, where you can spot out a chocolate cake and kind of focus on it. That, those kinds of pathways are activated by sugar. It wants to stimulate what we call foraging. And so, it will stimulate impulsivity and things, and like increase your wanting to move around. And in fact, we've linked sugar intake to ADHD and to bipolar disease, and others have too. And chronically high sugar is a risk factor for dementia. And if you give sugar to animals in high concentrations for a long time, they will actually become demented. They'll actually develop having trouble getting through a maze, and they'll show changes in their brain that are similar to what you see in Alzheimer's. And in studies in Alzheimer's patients has shown that they have about 5 to 6-fold higher levels of fructose in their brain. And so interestingly, it's probably not just from eating sugar, but also from making sugar. And a physician at Yale, a wonderful scientist by the name of Sherwin, did these studies in people where he gave them glucose, starch, and he gave it intravenously, though, the glucose, to bring the glucose levels up, sort of almost like what you see in diabetes. And then he measured, and fructose levels started going up in the brain. So, the body can make fructose. It's been shown in people. Been shown in the brain. And it looks like it's very important in a lot of diseases. We recently published a big paper on the association of fructose as possibly being the primary cause of Alzheimer's. We did this study. The paper was published with Dale Bredesen and David Perlmutter and other neurologists. And it was published in a very highly peer-reviewed journal. And it's the only current hypothesis that explains all the risk factors for why people develop Alzheimer's, and how it would work, how it might cause the disease. So I think the data is actually pretty compelling. And so I would recommend that we all try to reduce our carb intake somewhat. I'm not telling you never to eat sugar. I eat sugar, as you pointed out, occasionally. It isn't like we should never eat it, but we should really cut back on sugar. We should really cut back. You should probably never drink a soft drink. That is just really bad. And try to reduce the carbs we're eating, increase the protein a bit, reduce fat. It turns out that if you're on a real low carb diet, you can't make fructose, and it's hard to get fat because the fructose is what triggers appetite and food intake, eating extra food. So that's why if you're on a low carb diet, it can be a high fat diet, and yet you're not going to really gain that much weight because you're eating stuff that could make you fat. It's just that you're not going to eat that much because you're not that hungry, because you're not making fructose. But there is some data that fats can be bad, particularly if you're eating sugar. Then the fat's kind of potentiated. So if you really want to make an animal fat, you give it sugar and fat. Fructose alone makes you hungry, but it doesn't really make you gain weight unless you give the fat with it. But fat alone won't make you fat unless you give it the sugar with it. So they're kind of like they're playing a role together.
Why on earth would the brain produce its own fructose if it's literally damaging to the body?
Well, in the short term, it's probably helpful. So it turns out that animals in the wild, and my book, Nature Wants Us to Be Fat, includes studies we did in the wild. So we figured, why would anyone want to be fat? Why would we want to be diabetic? And and oftentimes nature has the answers. So it turns out that some animals want to be fat and they want to be insulin resistant, but only for a short while. And so this is like animals that hibernate, or animals that have to fly long distances, like from Alaska across the ocean to Australia. I mean, you've got to be able to have enough fat on board that you can survive if you because you're going to be over water for a long time. And so animals use this, and they would make fructose or eat fructose as a way to stimulate their food intake. And then they would store up the fat, and then they go on their trip. And so part of the way fructose works, originally we just kind of focused on it stimulating fat production and reducing metabolism, kind of the classic things we talk about, insulin resistance. I was just focusing on that, what we would call the metabolic syndrome. But then we realized, as you pointed out, that there are all these brain effects. And so why would there be these brain effects? But all the brain effects are focused on trying to stimulate an animal to forage for food. And when you forage for food, you want to be able to move fast, so it stimulates locomotor activity. If you give this to animals, they get hyper. You want to be able to not deliberate. You don't want to be focused on one thing for a long time. You've got to go into an environment and be looking around like a scout. You have to kind of look everywhere. You can't concentrate on any one thing. So the areas of the brain involved in deliberation and concentration, they're all blocked. Yeah. And so that you can see everything really quickly. It activates visual cues so you can pick out that food. It makes you brave. It makes you impulsive. You've got to be able to go into areas that are dangerous. You might have to go into a place where there's a predator. And so you have to be able to be aggressive. So these are all survival moves. And it's meant to help the animal find food and increase its fat stores because it's sort of worried that there's going to be a period of time when there's no food around. And the way that fructose works is it drops that active energy in the cell, which is a warning sign that there's not enough food. There is food because it's all going into the fat, but you can't, when you eat fructose, you can't break down the fat. There's a block. So you're just living off that low energy, the ATP, and it's kept low. So it makes you hungry, makes you forage, you're looking for food. And then when the fructose wears off, everything's okay. So it starts off as a temporary thing, and it's just, for the first hour after you eat sugar. But if you're eating sugar all the time, the way this works is that it's causing oxidative stress. It's causing stress to those areas of the brain. And initially it's transient, it's temporary, it's completely reversible. But over time, it starts to damage the energy factories, what we call mitochondria. It damages other things. And pretty soon you're kind of going to a low energy state all the time. And now guess what it is? It's the area of control that's the low energy state. So you have less self-control. You're going to eat more. It goes to the memory and starts to affect your memory. It makes you impulsive more because it's blocking the deliberation centers. And it may have a role in things like the development of ADHD and manic and even both mania and depression, and also causing dementia. So these are chronic effects of what was meant to be something that was beneficial. Mm-hmm. So it's unbelievable. Nature wanted us to be able to get fat to help us. And we actually even had mutations in our past that made us sensitive to this pathway. We are more sensitive to sugar than some animals because of what happened in our past. And it was all to help us. But now we're in a world where food is available 24/7. We can get sugar all the time. We don't have to wait for fruit to ripen. We just can go to the store and buy a candy bar. So it's unfortunate. We're a problem of our own success of being able to generate all this food. We don't have to, exercise. So we're doing all, we can drive. So all these things which were meant to help us, they do to some extent, of course. But what happens is now with all these foods that trigger it, we've triggered a biologic switch to make us want to eat more and so forth. And so that's happened on top of this society. So the trick is to try to not trigger the switch and also to stimulate repair of those mitochondria because we've been damaging them. So my book really focuses primarily on what activates it, what foods activate it, which foods are good, which foods are bad, which fruits are good, which fruits are bad. And I think it's a very valuable book. I have a chapter that focuses on the evidence for how to repair the mitochondria. And currently the best way is exercise, and you want to increase your muscle mass for sure, but you also want to do endurance type of exercises that stimulate the energy factories. And so the book really has these two parts, let's block the activation of the switch and let's stimulate how to repair what's been damaged. And I honestly think that this, coupled with these new medicines that are interfering with these pathways, is going to lead to a cure of these diseases in the next 20, 30 years. And so I do believe, I'm very feel positive about this. I don't think they say, well, 1 in 3 people are going to be diabetic. And I think we're going to stop this. Not only because we understand it and we can do it with diet and exercise, but and some help, from the putting taxes on certain foods and trying to reduce it. and these medicines. So I feel very good about the future when it comes to metabolic diseases
Mm.
and cancer and so forth.
Mhm.
So we still have to work hard on climate change.
Have you
That's an
seen
area.
Kiss the Ground? Have you seen the documentary Kiss the Ground?
No, tell me about it.
Oh, Dr. Johnson, it is one of the most hopeful, uplifting, amazing films. It's about climate change and some elegant solutions that can solve it in our lifetime.
Yeah, I believe in I totally believe as a scientist that we can fix climate change too. I really believe that there's a lot of very smart people out there. There's a lot of potential solutions. I do not, but I do want us to act on them. But there's a lot of great ideas.
Yes,
You know,
yes,
I think, yeah. I mean,
yeah.
we could do a separate thing. I do a lot of studies on climate change. I don't know if you know about that, but
No.
I'm pretty active in the field.
Wow.
So, but
You're
more
going
from
to
the
love this film. You're going to be
yeah,
so
more from the
excited.
medical side. I'm kind of an expert on the medical issues related to climate change.
Like, what do you mean by that?
Well, so there's what causes climate change, right? And the science of that. But as temperatures rise and there's more forest fires, it leads to certain illnesses.
Mm,
Our group was one of the first ones to identify the first big epidemic from climate change is an epidemic of kidney disease, and our group was very instrumental in making that linkage. We were the first ones to link the climate change with this epidemic of kidney disease that's occurring in Central America and India and so forth. It's
really?
almost a separate talk, but
Wow. Yeah, yeah. I just was curious. Oh my goodness. All right, so I'm going to just do a quick recap, and then I'm going to bring us back to uric acid because I know that was the thing you were really hoping to
yeah.
talk a bit more about. So the bottom line is this: is that within our bodies are these brilliant mechanisms that are triggered, and they stimulate foraging, ADD like behavior, like I got to find food. Where is it? Where is it? Impulsive behavior, binge eating, compulsive overeating, all of those behaviors. And once that switch has been flipped, the calories, the fat that we eat, the foods that we eat will get converted to fat. And this is a good thing because in the fall before winter, especially in northern hemispheres, we went
Right.
6 months in Canada, 6, 7 months of long, cold winters. And I can't even imagine attempting to make it through a Canadian winter just with what I could get out in nature. Like it's just unthinkable. Of course, our bodies knew that we were heading into famine, we're heading into winter, and I got you. I got you. What's going to happen is as the fruit's ripening, you're going to eat it. It's going to stimulate something. You're going to eat a lot of it. You're going to binge eat on all the berries and the peaches and the apples, whatever you can find. I'm going to make you. I'm going to compel you to binge eat all of these fructose rich foods, carbs, and then you're going to get really fat and you're going to survive the winter and you're welcome. But
And you know what? I just have to add,
yeah.
it's also important in the southern hemisphere and in the hot areas because things like lemurs will do the same thing. They'll eat a lot of fruits, and then even though when the hot dry season comes, they'll find a little hole in a log or a tree, and they'll hibernate. But in hot climates, it's called estivate. And when they do that, they're also living off their fat. But one thing that fat does is it produces water. And when they break down the fat, they're also producing the water that they particularly need during the dry season. And that's also why whales, they'll burn their fat, not just, they use the fat as insulation, but they also use it as a water source. They get about 1/3 of their water. And that's also probably why dehydration stimulates this pathway, because if you make fat, it's a way to produce water. And so
That's so
mild,
interesting.
yeah. So mild dehydration will stimulate fat production, but it's just mild. But if the dehydration's severe, then you don't want to be making fat. You want to be burning fat.
Right.
So if you look in the desert, animals like camels will have a hump, and a lot of animals will have fat tails because they want to put the fat someplace. If they put it on their body, it'll insulate them and it'll make them hotter. But so in the hot climates, they usually put the fat kind of like on a ball on the neck or on the back or in the tail, somewhere where it doesn't have to insulate. But if you're a sea mammal that has to dive into the real cold water, then you want that fat all over your body, right?
Oh my gosh, that's so brilliant. So maybe this was in your book. If it was, I forgot. Is the hump on a camel fat, not water?
Yeah. When I was a kid, I thought it was water.
Oh,
And I wasn't way off. It's fat, but when the camel is really in trouble, it will start to burn the fat, and the hump is another source of water. So it is like a canteen.
wow. So interesting. So in the southern hemispheres, the same pathway exists. When you start getting dry and hot and dehydrated, the fruit will stimulate fat production, which will create some stored water on the body. Whereas in the northern hemisphere, the fat is a source of energy to survive winters.
Well, I would probably, it is true that, like it's really in the tropics and the real hot regions where the fat is used for both water and energy everywhere. But water is really important in these areas where there's a dry season.
Mm-hmm.
But like when the bear's hibernating in the north, it's using that fat for both calories and for water. The bear won't drink for 4 months, right? While it's hibernating, 6 months.
Mm-hmm.
So when it's hibernating, it gets its water from the fat. So the fat is a major source of energy, and it's also a source of water.
Hydration.
And that's why when you understand what fat's for, then you understand why mild dehydration and eating salt stimulates fat, because it's trying to make the body feel like it needs water. So one way to need water is to drink a lot, so it stimulates thirst, but it also tries to make fat as a way to help the animal if there's not enough water around.
Right, right. So so the bottom line is that even if you are awakened to the fact that we need to stop eating or significantly reduce our refined carbohydrates, some people go, oh, I just eat potato chips or corn chips, or you know what I mean? They'll go to other salty foods, not knowing that potentially there's still this mechanism in play that's intended to save your life. It really does have your back, but we need to understand that we've tripped this poor mechanism into 24/7, 365 mode, which is will just continue to get fat sick and what does Joan Iflin call it?
Yeah.
Fat sick and crazy.
Yeah. Yeah, there's a story for it. It's called the thrifty gene. And what it means is that if you go back in time, during periods of history where there wasn't food and where there wasn't enough water, animals adapted to try to find ways to maximize their ability to survive. And this happened with us. So we've actually identified 2 mutations that humans got that occurred during periods of stress when there wasn't much food around and there was starvation. And one was this mutation to raise uric acid. So humans have much higher uric acid than most animals. And what since the uric acid is used to help to activate the switch to gain weight, and it's triggered mainly by fructose. When we eat fructose, we get a whopping uric acid response. Whereas if you give the same amount of sugar to a mouse, for its weight, the mouse won't get a big reaction. So, the sugar industry says, to make a mouse fat on sugar, you have to give it a lot of sugar. That's not practical compared to humans. That's because the mouse is less sensitive. But we had a mutation so that we are very sensitive to sugar. And in fact, if I take a mouse and I create that mutation in the mouse, then it becomes very sensitive to sugar as well. Wow. So we are sugar sensitive, and we love sugar. And, we have this sweet taste. And there's very few people who don't like chocolate cake. There are some, but there are very few people who don't like a beautiful dessert. And it's because we're wired to like this stuff. And so you can imagine, it's a perfect storm now because we've had these mutations, these thrifty genes, what we call, that make us more sensitive to these foods so that we can accumulate fat, which was a survival. It helped us survive back when there wasn't much food around. But now it's like, oops.
Oops. So why, I wonder, would people let themselves get dehydrated? Like, I know if I'm hungry, I eat. If I have to go to the washroom, I go to the washroom. Like when I'm tired, I do my best to get to bed, right? But when there's thirst, why are so many people not hydrating themselves, do you think?
Well, there are people who just are what we call low drink, or, they don't drink enough. They
Right.
tend,
Why?
tend to be low volume drinkers, then they tend to be the people who become overweight. And there are people who like salt. And one of the reasons people like salt is that feeling of a slightly high salt concentration in your blood. And we have a taste receptors for salt that make us, like the taste of salt, on our taste buds. So nature tried to train us to pick foods that would help us store fat. So one of the taste buds is sweet, and so that was to help us pick out foods with fructose. Another was salt. That was to help us raise our salt concentration to activate this same pathway to gain weight. That's why deer love salt licks. They'll look for these salt licks, and it's been shown that when they find these salt licks, they can gain weight easier. In fact, some places people will give salt to domestic animals to try to increase their weight. And then there's another taste called umami. And that umami taste actually is a receptor to take foods that will raise our uric acid directly. So it turns out that the three tastes we developed are all aimed to help us identify foods that could kind of activate this switch. So we're really, it is a perfect storm. And the two tastes that, like bitter and sour, were meant to avoid foods that, could be dangerous or toxic. So
Goodness.
we're sort of wired. So there's a lot of people who like salt, and if you want to raise your salt concentration in your blood, one way is to eat a lot of salt, but another way is to drink too little water. And so there are people who tend not to drink a lot of water, and they know they should. And
Yeah.
I recommend
My
taking a
mom.
glass of water with each meal and put it in front of your meal and force yourself to drink it before you start eating. And it's not hard to drink a glass of water. It's just we don't think of it. And I'm in that group that tends to drink too little.
Yeah.
My natural tendency is not to drink a lot of water. And I know that that's not good for me. And I was overweight. I was never obese, but I was overweight for many years. And I probably still could lose a few pounds. But basically, by following just simple principles, you can, and some of which I lay out in my book, it's pretty easy to get your weight down to normal BMI.
So all of these tastes, umami, salt, and sweet, are literally designed so that we don't starve. We don't
Right.
starve because no animal wants to starve. It's terrifying
That's it.
thought.
It's like the basics of life. You want to make sure you have enough energy, which is calories, enough water, and oxygen. And actually, this switch also helps protect animals from a low oxygen state. They did this study in these animals that burrow in the sand. They burrow in these holes. There's very low oxygen in there. And they'll start making fructose, because when you make fructose, it decreases your oxygen needs. And one of the reasons is the way when we make our energy, this ATP that we're making, it's made in the mitochondria. That's where a lot of the oxygen we breathe is used, is to make energy. So if you make less energy, you use less oxygen. So it turns out that these animals will switch to fructose in a low oxygen state. And actually, we found evidence that other animals do this too. In a low oxygen state, they tend to make fructose. And even in early pregnancy, fructose is made before the egg before placentation and the placenta gets a large blood flow. So fructose can be good in these cases, but we're eating so much, we're putting it in overdrive, right? So, and cancer cells love fructose because they have to metastasize. They don't have oxygen supplies when they first get into tissues. They're kind of living in a low oxygen state. So there's really good data that this pathway is like playing a direct role in stimulating cancers. And we actually have shown that, the fructose in this pathway can stimulate breast cancer metastases, for example. And so it turns out this is a really important pathway that was meant to help us survive, but in overdrive, gosh, it's driving dementia and cancers and behavioral disorders and obesity and metabolic syndrome and diabetes. And it's all based upon a kind of an evolutionary biologic pathway that was really meant to be good. But how could we do this? Well, it's because of nature.
Mm-hmm.
And of that. So the good news is once you know what's going on, it's really something we can make a big dent in. It's easy to find foods that are great that do not do this. And a lot of people have kind of discovered it the hard, by just practice, that low carb diets, why do they work? Now we know why they work, right? Keto diets, why they work. And we can explain other diets too and why they work, because we understand that fats are important because they're the fuel that makes you fat, but the carbs are what make you hungry.
Mm-hmm.
So it starts to make sense.
And when you look at the diet wars, like on one end, you've got the whole food plant-based, low fat, high carb, low fat, right? And then we've got the other end of the spectrum, high fat, low carb.
Yeah.
And you can see that the whole food plant-based people are not saying high fat, high. They're not. They're not getting good results by putting people on high fat and high carb, right? That's where things go sideways, and that's where they're the most addictive. That's where those foraging behaviors are most, kicked into gear.
Yeah. And one of the problems with the high carb, low fat is, although it does cause weight loss, the high carbs still make you insulin resistant. They still stimulate the foraging. So the high carb, low fat is not a great solution. And we've studied this and, but in terms of weight loss, you can, by just reducing fat, you can reduce weight, but
So
it's not enough. Now, there are these new studies that, are linking seed oils with a lot of problems, and people are sending me papers suggesting that there's a fructose seed oil interaction. And we know, for example, that you can block some of fructose effects with omega-3, the good fat. And so it is an area that we need more studies in. So there could be a story there that could unravel, but for sure we know that fructose activates this pathway. We know that fats drive caloric weight gain, but we're also learning that there may be more things going on that we can learn from and may be important in the long run.
Mm-hmm. Let's wrap up with uric acid. So I don't have gout. So anyone who doesn't have gout, that's only 9 million or whatever. We're like, oh, we're good. But is that true? How do we know if uric acid is affecting us, even if we don't have gout?
Yeah. So gout is, when you actually have those crystals in your joint and you're in pain, but you can have a high uric acid in the blood without gout. And a high uric acid in the blood is also a major risk factor for obesity and diabetes and fatty liver and hypertension and heart disease. And there are many studies that suggest that lowering uric acid can still be beneficial, even if you don't have gout. It's not absolutely proven, but there's probably 100+ studies out there that show benefit. And so my recommendation is, we try to reduce foods that can raise uric acid a little bit. Beer, for example, is one of the big culprits. And it's not just the alcohol, but the brewer's yeast. And so, we should be reducing foods that can raise uric acid for sure. Certain, vitamin C, which is a vitamin that everyone should probably be taking. it lowers uric acid, and maybe 500 milligrams twice a day. I recommend it. It definitely has been shown in beautiful controlled trials to lower uric acid a little bit. If your uric acid is really high, see your doctor and discuss it with him. There are people like myself who believe that if your uric acid's over 8, for example, that maybe you warrant going on a drug to lower uric acid, but you need to coordinate this with your physician and discuss the pros and cons.
Mhm.
But yeah, coffee, drinking a lot of water, these help lower uric acid. There's supplements like quercetin, and I know Dr. Perlmutter promotes that. So there are different ways to look at it, but I do think that high uric acid is bad. I do think that you should get checked. If your uric acid really is high, you should try to do something about it.
Is there a
Drink
test that
more
you can ask?
water.
Drink more water. Can you ask your daughter for a
Exercise.
uric test? Will it?
Yeah, you can ask your doctor for a uric acid test.
Okay.
Yeah,
Okay.
I think we should do it.
Okay.
There's enough data that it's a very powerful risk factor.
Okay. Got it.
They can look up my papers. I've written
Okay.
over 200 papers on uric acids.
Wow. Wow. I don't know how you have all this, how you've been so prolific, like how you have enough time and energy for all that you do. Amazing. This might be a cheeky on the fly request. Do you have access to your poem from the back of your book?
I don't have it here.
Oh,
I might be able to find it. I believe I have a copy of my book over by my desk, but
it would only take you a second.
Oh, actually, you know what? I might be able to pull it up.
Okay.
Want
Okay.
me to do
I
that?
just thought what a beautiful way to end this interview, to share your poem. I
Yeah.
listened to the book on Audible, so I don't have it to read.
Okay, hold on one second. I think
Yeah,
I can
take your
find
time.
it.
I might just take a little
Okay,
moment to summarize, or have you got it?
I think I've got it.
Okay. Awesome.
I believe this is the final version, but it goes like this. An ode to sugar. From the good earth, the green grass grew, common and ordinary, except to those who knew. For the cane's sweet sap could be made liquid and pure at the boiler houses by hard work, sweat, and tears. From the toil yields a virgin white powder, delicate and soft, crystalline in beauty, as precious as gold, sweeter than honey, a secret untold. With a swish, sugar makes foods reach new heights, fluffy cakes, creamy frosting, and chocolate delights. With crystals like snowflakes, like stars of the night, sugar sparkles like the sea in twilight. Sugar brings dreams of fairies with frosted wings, living in gingerbread houses with marmalade lights, a fantasy of pleasure, of happiness and dreams. Like an enchantress it conquers, like a songbird it sings. For those whom you love, give flowers and sweets. Sugar brings romance and loves everything. But woe to those whose desires lead to too much, for they fall into trouble as with Midas's touch. What was once driven by want is now forced by need, irresistible, overwhelming, uncontrollable, and mean. An addiction of sorts one cannot live without. What was once consumed now consumes oneself. What once satisfied the heart now takes from the soul. What once brought love now leaves one's heart cold. Such a desire for sugar cannot be relieved. A devil's curse has been issued. Poor prisoners are we. The body responds with fury against the dark force. In a heave, it floods its blood with sugar, trying to stave off its cursed course. Yet the body still rots, taking its toll. What was once young and strong becomes fat and old. The teeth, once white, are now rotten and stained. The liver becomes fatty, the kidneys shriveled and inflamed. Blood vessels are fatty and may close off or burst, and the heart becomes swollen and diseased all in course. And while once Cupid's honey-dipped arrow brought love and romance, now the sugar-sickened tip pierces the heart like a lance. So this is actually an earlier version. I have a better version in the book.
Oh,
So
That was so good. So good. Ah, say it like it is. Is there any final words you'd like to share today before we wrap up?
No, I thank you for, I would like to tell people that, there's a lot of science that's coming out that really is making a difference, and that we should view the future as positive, and that there are many things we can do to really get our health back. And that, I think the book would help a lot of people. But I think just understanding the importance of sugar and reducing the amount of carbs that we eat could have a big impact, and drink more water.
Thank you. And I just want to add that if you're falling, it's a little controversial to say this, but if you're falling for the hope that there's a pill that can reverse the damage that fructose is doing, our refined carbohydrate consumption is doing, our dehydration is doing, our lack of exercise, all that, there just isn't. That this is the solution. If this is the real solution, as unpopular as it might be for some people, I just want the pill. Give me the GLP-1, thank you. Right? Really, at the end of the day, that's a bit of a band-aid. It might help maybe for a bit, or maybe, but this is upstream. This is the root cause. And we heard it from Dr. Johnson today. Thanks everybody for tuning in.
Thank you, Florence. Bye.
I hope you enjoyed this interview. And before you go, do one more thing. Stop, think back on the interview while it's fresh in your mind, and write down your favorite takeaway in a special dedicated journal. If you do this, at the end of the summit, you'll have a page or two of nuggets of wisdom to guide you forward. And remember, this is just the beginning. At the end of the summit, you'll be invited to attend a free webinar where I will personally summarize the key insights of our speakers and pull it all together into a practical plan of action. You can also check out our Facebook page where you can connect with others and ask questions, and our Kick Sugar Coach podcast and YouTube channel for additional inspiration. Thanks for tuning in. We'll see you in the next interview.